Okay, so we're done with density and specific gravity. Let's go to fluid pressure. So for pressure, as I said, pressure is basically force per area. But strictly speaking, it's actually, remember, pressure is a scalar quantity. The average pressure on a surface A due to a force F is defined by, it's basically the perpendicular component of the force over area. It's not necessarily the force, but it's actually the only the perpendicular component. Kasi pwede rin kasi na yung parallel component mag-act and hindi yung pressure. They have the same units as pressure but it is not pressure, it's actually shear. So merong tinatawag na shear which is F perpendicular over area. Yan. So yon. So shear stress. So you have pressure and stress having same units. Hindi natin kasi tinakal ang elasticity and in 71. That is a tackle ngayon yun, wala tayong oras. But the point here is for pressure, we are taking the perpendicular component over area. For shear, usually it's the parallel component. Yun yung hinahanap ko kasi it will slide down. The effect of the force is to slide down the particle. And for pressure, it is to push the part to push that area with some force. Okay, so some books will write P as capital P, some books will write it as small p, it doesn't really matter, pero yun yung ibig sabihin natin for average pressure. For the pressure at the point is just the derivative of the perpendicular component of the force per unit area. So basically what you just have here is parang kumbaga yung velocities lang natin than before, average velocity and instantaneous velocity. Yung isa ay change, yung isa ay derivative. So parang ganun lang din yon. So the pressure at a point is given by dF perpendicular over dA. Okay, the SI unit is pascals, which is 1 Newton per square meter. Meron siyang unit which is Pascal. And then this quantity here usually given din to sa exam. You have atmospheric pressure ATM. One atmospheric pressure or the pressure exerted by the atmosphere on us in the ground is about 1.013 times 10 to the 5th kilograms per square meter or 1.013 times 10 to the 5th pascals. So, or 101.3 kilopascals. So pakialala tong units na to or kung if ever man paki-check yan kasi gagamitin natin siya for a lot of problems in this topic and in the next topic. Okay, sige. Now, fluid pressure. Consider a volume of fluid with volume ADY. Ang gagawin natin, remember, force per unit area. But however, medyo mahirap siyang gamitin for, in general, for a fluid kasi paano ka nga naman measure ng forces dyan? Instead, we will derive another expression for the pressure inside the fluid at a distance of h from the surface of the fluid. Okay, ang alam natin by experience is that the pressure in a fluid increases with depth. Diba? For example, nag-swimming ka, tapos habang lumalalim ka, bumibigat yung push sa'yo ng water kasi mas ang dami ng water na nasa taas sa'yo at tapos so at some point lumalaki yung pressure ng fluid in the body as you go down as you go deeper into the ocean, for example. Okay, so we have that experience. The question now is this actually true? So let's consider this this volume of fluid here, which has a height dy, and then let's say that the surface of the area of the fluid is about A. And then we know that pressure increases with height. So in that case, mag-exert ng force yung upper column ng fluid, mag-exert din ng force yung lower column ng fluid. Okay? And let's say that at the top it's P plus dP, at the bottom is it's just P, and then the force is just P plus dP multiplied by A. So let's say dP is the infinitesimal change in the pressure kasi balit lang naman yung height difference. Okay? So in that case, by Newton's second law, ang lalabas is that, of course, since this fluid here doesn't accelerate downward, hindi naman mag-accelerate downward yan. So ang mangyayari lang ay mag-stay siya dyan, therefore, all the forces are in equilibrium and hence the net sum of all forces acting on Y is 0. And then from there, you can now substitute this expression here. So ano yung tatlong equations na yan? So from here, PA here is the force exerted. This is the force exerted by the bottom surface. So ito yon, bottom to. On the other hand, this term here, which is downward, is the force exerted by the top. Remember, force is pressure. pressure is force over area. And hence, force is just pressure times area. And thus, for this term here is the force exerted um, force exerted from the bottom, which is acting upward, kasi nga parang sinasandwich siya, yung column ng fluid natin sinasandwich. And then this is the pressure at the top. And then this one here is basically the total volume in the fluid multiplied by the, which is basically the weight of the fluid. This ADY here is the volume. Tapos this rho times V here is basically your mass, and mg is the total weight. Therefore, this is the weight of the fluid. Okay? So in that case, ang mangyayari lang ay you can simplify these terms here, and so that dp dy is minus rho g, and therefore the density is now dependent on the height of the fluid. So from here, the density, if P naught, syempre, syempre makakita ka ng derivative expression dyan, you need to integrate it, and therefore meron ka dapat initial conditions sa tinatawag. So ano yung initial, ano yung pressure at some height, at some initial height, y? So in that case, let's say P naught is that pressure at the surface of the fluid, which is actually given by the atmospheric pressure. Then the pressure at the depth h from the surface is given by P equals P naught plus rho g h. Okay, h here, this is important. H here is measured from the top towards bottom. Okay, hindi siya from the bottom towards top. Okay, malilito. H is from the top pababa. Weird siya tisipin, pero ganun talaga siya mina-measure. Top to bottom, not bottom to top. Top to bottom. Okay, so again, pressure increases as you go deeper from the surface of the fluid because H here increases. Okay, questions? May tanong ba? May tanong? Okay, again, the pressure of a fluid is some initial pressure P naught, which is, if this is an open fluid, it's just the atmospheric pressure P atmosphere, plus the density, times the acceleration due to gravity, times the height from the surface towards the bottom. Okay, H denotes the depth of the particle. Okay, so yon. So from here, ngayon, let's look at different cases. So for example, if you have a uniform fluid here and it's open in air, then this P naught here becomes the atmospheric pressure because the atmosphere will push will exert a force on the surface of the fluid. Therefore, may pressure pa rin yan. Okay, and hence, if this is a point that we're considering, the total pressure exerted on that point is just P naught plus density times G times H. Okay, wala tayong issue dyan. However, what if we have three immiscible fluids? Let's, for example, we have, let's say, oil, water, and let's say juice. That they're immiscible. Ibig sabihin, hindi sila nag-mix. Ang mangyayari dyan, there will be a force, a pressure exerted from the top, para mahanap mo yung pressure at the bottom, let's say at point O here, you need to sum up all the pressure contributions of the three different fluids. Given, for example, that the height of the first column of fluid is, let's say, H1, for the second column, let's say it's H2, for the third column, let's say it's H3, then the total pressure is additive. So you have the pressure at the surface, P naught, plus the pressure from the surface towards the bottom part of the first fluid, which is rho 1 GH1, plus the density from the top of P1 to the bottom of the second fluid, which is rho 2 GH2, and so on. Ganun lang siya. So the point here is pressure is additive scalar quantity yan. Okay? Questions? Questions?
None po.
Okay, sige. Now, an important consequence here is regardless of the shape of the fluid, the pressure is the same at any depth. So, for example, here, if you have different shapes of the fluids here, kahit isang malaking ocean yan of fluid, hindi nagmamatter kung ano yung shape ng material or yung shape ng fluid column. Importante lang is dapat same ng height. Same pa rin yung exert the pressure. It doesn't depend on the shape of the object or of the fluid column. Okay? So yon. So wag malilito. Bisa kasi may panditong item na nakatagilid naman siya, pero the point is the height is the same. Therefore, the pressure should also be the same. Okay? Questions? May tanong?
None.
None. Okay. Okay, so now let's define absolute and gauge pressure. So there are two pressures that we can consider pag medyo nahihilo ka. Ano raw? Okay, absolute and gauge pressure. So the absolute pressure has a contribution from the pressure due to the atmosphere. Um, kaya nga siya tinatawag na atmosphere na absolute pressure. It has the contribution of the pressure due of the atmospheric pressure is there. However, for gauge pressure, the atmospheric pressure contribution is zero, so therefore it cancels out the atmospheric pressure. Hence, gauge pressure is zeroed at atmospheric pressure. Absolute pressure is zeroed at perfect vacuum. That is if P equals zero. Siyempre sa vacuum, wala namang pressure yan. Okay, so bakit importante yung difference na yan? Kasi for example, if you have a car and you want to fill that car wheel with air, ang minemeasure na pressure dyan ay gauge, hindi absolute. Kasi kung absolute pressure, you need to add the atmospheric pressure there and baka magkamali ka ng calculations. So, kaya hinahanap dyan sa mga gulong ay gauge pressure, not absolute pressure. So, medyo tignan mo mabuti if you are checking, halimbawa, nagsasagot ka ng FQ or kung ano man ginagawa mo, please check if your pressure that you're calculating is gauge pressure or absolute pressure. Kasi may ina-add ka na factor kapag absolute pressure yan. Okay? Questions? May tanong? Wala?
None po.
None. Okay.